Measuring line segments. The instrument used to measure a line segment is called a straight edge, a ruler, or a yardstick, or a meter stick. So line segment symbol, we use that little bar, and that's kind of out of place. It should be like up higher. Remember, that's what we saw in the last slides where the bar would be on top up here. So it looks something like this. And that would signify it as a line segment. In figure 1.12, we see that that measurement of that line segment is 5 centimeters because we express the length of RS by with no bar. So we can say, like we talked about before, is if we just want to talk about its length, we can just say R. I'm trying to write that as italicized. RS is equal to 5, and that signifies that the line segment is equal to 5. Midpoint. So we're looking at line segments and measures of line segments. One thing we want to talk about is the midpoint of a line segment. So midpoint basically saying is that if we have line segment AC and it's identified that B is the midpoint, then we can go ahead and we can deduce that we know that AB, so line segment A to B, would be congruent to line segment B to C. So one way we symbolize that is we can put a little mark right there on that line segment and a little mark on that line segment, and that signifies those two are exactly the same, and therefore they're congruent. Notice the symbol for congruence is this guy right here. That little symbol, it's like an equal sign, like a little whooshy thing on top. So like an equal sign, and you got like a little up there. And I apologize, I didn't pay attention that this is kind of all messed up, but we got the idea here that those are symbols and our labels. All right, angle measurement. And we'll just go ahead and run these two videos together. So angle measurement depends on the length of sides, but on the amount of opening between the sides. So not on how long these sides go on for. So it's not how long B goes to A and goes on forever. It's how much is inside of right here. It's this part that we care about, or this part that we care about. Those arrows do signify that those side lengths, so those sides of the angles, go on forever. To measure angles, we use a tool called a protractor. And with a protractor, we're just going to lay down and kind of see like that, it's like we've got some other examples of a protractor if you haven't used one before, but this would measure as a 50-degree angle. So you go off of one side and you measure up to the next side. One thing to see about a protractor here is that to kind of keep in mind that you line up the vertex at the center point. And then when you read your angle, if it's an acute angle, we'll use our numbers on top, because you'll notice this is 10 degrees and then 20 degrees and then 31 degrees. Versus on the bottom, that would be our measurement coming from the other side. So here it starts at 0. We can use the bottom measurements going around, and we can see if this was a 150-degree angle, it'd be going from here around to there, or 149, excuse me. So using a protractor, just kind of making sure we read that correctly, but I would imagine that most of you have used a protractor before. All right, so take a look at this angle right here, and we figure out that would be 31 degrees. One thing that is missing right here, and like I said, I think this is because it's like going from PowerPoint to Google or to PDF, and it just left off. And so we can say that the measure of angle RST is 31, or the measure of RST is 31. So here we have the degree symbol, here we have 31. We can say it either way, it's understood to be degrees. All right, nope. Make sure I didn't go too far, there we go. All right, so on a line sheet of notebook paper, so if we had like regular school notebook paper, those lines that we see on that paper are parallel lines. So parallel lines lie on the same page, will not cross or over each other, even if they are extended indefinitely. So they're equal distance from each other. Parallel lines are signified by lowercase variables, italicized lowercase variables. We say that line segments are parallel if they are parts of parallel lines. So like if RS and MN are parallel, then we can say that the line segment MN and line segment RS are parallel to each other. Looking at figure 1-20, the sides of the angles ABC and DEF are parallel. So the sides AB and ED are parallel to each other, and the sides BC or CB and EF are parallel. So use a protractor to decide these angles have equal measurements. So if we laid a protractor down there, we would see that angle B is 44 degrees and angle E is 44 degrees. Two angles with equal measures are said to be congruent. So in this particular case here, we have a larger angle ABD. We did a bisector. That means that angle ABD was bisected. If it's bisected, it's cut into two equal parts, and therefore 33 would be congruent to 30, or I'm sorry, angle ABC would be congruent to angle CBD, and that's called a bisection. Straight lines, super important information. Definitely want to write these vocabulary words down. So like on this one, what's it mean to bisect and so forth. Each one kind of jotting down the things or printing them out. So the key thing to remember about a straight angle is always 180 degrees. So take away from that a straight line. A straight line is always going to be equal to 180 degrees. So if you have a straight line, it's 180 degrees. They're not opposite of that, but in addition to that, if we take a straight line and we draw a line into it that forms a 90-degree angle, we call that a perpendicular line. And if someone said, hey, I have a perpendicular bisector, then what we know is that RS is congruent to ST because this bisector cut it in half. So not only did it cut it in half, it's also a perpendicular bisector. So it's forming a 90-degree angle and splitting the line segment in half. When two lines have a common point, they're said to intersect. So in this particular case, line R and line T intersect, and so they have a common point. When two lines intersect and form congruent adjacent angles, they're said to be perpendicular. Ooh, congruent adjacent angles. Okay, so let's talk about what adjacent means. So adjacent means side by side. So like right now, angle 1 and angle 2 are adjacent to each other. So if they are congruent, the only way they could be congruent is if this is 90 and this is 90, because that straight line right there adds up to 180 degrees. So if these two angles are congruent, then they'd have to be exactly the same. So 90 and 90 adds up to 180. And then vice versa, we can do that all the way around. So like angle 2 and angle 3. So if angle 2 is 90 degrees, then angle 3 would have to be 90 degrees, and therefore we form perpendicular also. And just work your way around the intersecting lines to see how that applies. And then going back to look at midpoint as one more like little example to pull out of here is this idea that if I had a line segment AB, and AB is equal to 15, and we know that M is the midpoint, then we can go ahead and find out that we know that we can find half of this. So if this is the midpoint, that means that this guy is equal to that. If this whole thing is 15, so we can say 15 divided by 2, and that would be each line segment would be 7.5. So AM would be 7.5 and MB would be 7.5. All right. Same thing here if we go the other way. So what if I said that AM is 4.3? So let me just change colors. So what if I said that AM is 4.3? Well, we know that these segments are equal, so we can find the distance of AB by multiplying that 4.3 by 2 and find out that AB is 8.6. We can likely or similarly do this with algebraic expressions. So like for example, if we knew that the line segment, let's see, AB is twice AM. So if we knew that AM was 2x plus 1, and we wanted to find out how long AB was, then we could just take the AM and multiply it by 2, and that would tell us that AB would be that algebraic expression. So we can do this like with whatever situations we want, whether it be with simple numbers, going and cutting it in half, applying the half and doubling it, or doing it with algebraic expressions. All right, let's see. I think that wraps this up. So that's all of section 1.2.